particular video, I'm going to show you how to attack a few different types of momentum impulse problem, this being the first one. So in this first scenario, you have two carts, 1 kilogram, 2 kilogram, attached to a spring, initially moving to the right, and then the spring is going to uncompress, and then it's going to cause these two carts to separate. So if you look at this particular velocity time graph given here, it shows that the system is initially moving to the right at a rate of 2 meters per second. I know to the right because this is a velocity graph and the velocity here is above the t-axis. And then all of a sudden the two cars separate. The 2 kilogram mass, according to this legend here, the dark or the shaded filled in black dot is the 2 kilogram cart. It's going to speed up to a velocity of 2.5 meters per second. And then the 1 kilogram cart will slow down from 2 meters per second to 1 meters per second. Alright, that makes sense because if you think about it conceptually, here's the system moving together, and when the spring uncompresses, it'll push left and right. Because the system is initially moving to the right, cart 2 is going to speed up because the spring force is going to push it to the right, causing it to accelerate. At the same time though, it will also push left, so causing the 1 kilogram block to slow down because it's pointing against the 1 kilogram cart's motion. Okay, alright, so in that, it wants us to find the magnitude of the change in linear momentum. In order to figure out the magnitude of the change in linear momentum, you essentially have to find the initial momentum and the final momentum and see if there's a change. So let's go ahead and crack it out. Well, here initially the momentum of the system is given as m1, m2 times the initial velocity. m1 plus m2, why? Because they are moving together as one. So therefore here, the mass on the left is 1 kilogram, the mass on the right is 2 kilograms. So if you add those up, you'll get 3 kilograms. Well, what's the initial velocity? According to the graph here, the initial velocity is 2 meters per second. So I'm just going to go ahead and do a little plug and chug. The total mass of the system is 3 kilograms. How fast is it moving? It is moving at a rate of 2 meters per second according to the graph in the positive x direction. Okay, so if you simplify that, 3 times 2 is 6. So here I made a note that the initial momentum is positive 6. Why? Because it's moving to the right and momentum is a vector, so there has to be a positive sign. Now, well, how do we know whether there's a change? Find the final momentum. Well, according to this graph, the 1 kilogram block, according to this legend, slows down to a rate of 1 meters per second, still in the positive direction because it's still above the t-axis. The 2 kilogram block sped up from 2 meters per second to 2.5 meters per second. So all we have to do is really just plug and chug, right? Here, I'm just going to call the 1 kilogram mass m1. So it'll be 1 kilogram times the velocity here for the 1 kilogram after the spring uncompresses is 1 meters per second. So 1 times 1 is just 1. And then m2 is just the 2 kilogram block. Mass being 2, the final velocity being 2.5. So 2 times 2.5 is 5. 1 plus 5 is 6. So as you can see here, both these values are still positive. So therefore the final momentum remains the same, which is positive 6. So I'm going to say that there is no change, right? You start off with 6, you end up with 6 in the positive. So that hasn't changed. So I'm going to highlight A as my answer. Alright, the next one here is a little tricky, I think. Here, conceptually, you have a 2m mass moving to the right. It's going to collide with another cart with mass just m, though, with the same speed. It's just in the opposite direction. So as you can see in this diagram, this is v, that's v, except one's pointing right, one's pointing left. So if you think about momentum, right? Momentum here is 2m times v, because by definition momentum is mass times velocity. Well, what's the mass? This is 2m. What's the velocity? V to the right, so positive. The cart on the right is moving leftward, the mass being m, v being negative v, because the arrow is pointing left, so we actually have to subtract these two. But ultimately here, the question here, if you haven't read it yet, is this: which of the following best represents the momentum of cart of mass m? So it's not looking at the 2m, it actually just wants to see what's going on with this cart on the right of mass m. So conceptually speaking, initially this cart is moving leftward, so the initial momentum has to be negative. So all these graphs does show that the initial momentum of m is negative. However, it's what happened afterwards that allows you to pick the right answer. Well, 2m times v is bigger than m times v. This is positive, that's negative. So when you add them, this quantity is bigger. Because it's bigger, it says that the initial momentum of the system is pointing rightward. Okay, well, once this collides with this mass on the right side moving leftward, the momentum in the system still needs to be positive. Okay, conservation momentum tells you whatever it is you start with needs to be the ending quantity. So in this case, the momentum in the system is positive because this mass here is 2m, which is greater than m, so it'll overcompensate for this mass moving left. Okay, so that's the key, because in the final frame the systems will move rightward, and this m here will also follow the direction of the system. So it went initially was moving left, and then after the collision it moves right. So therefore I want to cross out this choice that's on the top left here, because it's saying the momentum remains negative and constant. I want to cross out this choice on the bottom left because it says, well, it does initially move leftward, but then it's saying after the collision it slows down but it's still moving to the left, which is no, that doesn't make any sense, because here's 2mv, which is greater than mv, so therefore when they collide the system will move to the right, which implies that this part is wrong because it's saying it's still negative, it's just less negative. Okay, now that leaves you with these two choices on the right side column. Well, I would cross out the bottom right because it's saying the speed after collision is the same, it's just in opposite direction. Okay, so therefore I'm going to cross this out. Why it does start negative, it's saying that after collision the momentum of cart M just switches. That's not the case. It has to slow down, because it slows down the momentum cannot be the same for that cart. So here's the proof for it mathematically. So this is going to leave with us just the top right choice. Okay, so here if you set up conservation of the momentum, the initial momentum must equal to the final momentum. Well, what is the initial momentum? The cart M2 is initially moving right, so that's positive. The mass M is moving left, so I subtract it. I want to take the difference. After they stick together, the total mass of the system is 3m. Well, what's the final velocity? I don't know. It's just some VF, right? I just know that it's going to be positive because this mass here is 2m, and the speed's the same, so it has to move to the right, favoring the heavier mass. All right. So if you simplify the work on the left side of your function here, 2mv minus mv just leaves you with just mv, and then mass cancels out. So to find vf, you divide both sides by v. So as you can see here, it's telling you and me that the final velocity of the system after collision is only 1/3 of its original v, whatever v is. So mathematically speaking, the block here, this is m times v, but then afterward is m times v over 3, which is smaller. So therefore this graph here in the top right makes the most sense, right? And it's positive because again the system is now moving to the right. All right, if you want, you can just write the statement for m by itself. The initial momentum of m is negative mv because the mass is m, the velocity is negative because it's moving left, and then I just found vf for the system, but because they couple together, the final velocity of this must be the same as the final velocity for this one. So here I just put the final momentum of block M is the mass itself times the final velocity, which is v over 3. Well, it's positive, so therefore the momentum here has to be positive, which indicates it has to be above the t-axis, and then the initial momentum has to be negative, indicating it's negative, except this part here cannot be the same because m times v over 3 is a lesser magnitude. Okay, I hope that helps. If you need to listen to that again. Alright, so I want to go with that choice. The next question is this one. This one is pretty light work. So here you have two objects, x and y, they collide, and then it wants us to know which of the following correctly describes the momentum and the kinetic energy of the system. So as you can see in the graph here, this is the velocity versus time graph. You have object x, which is in the black dot, object y, which is the just unfilled dot here. Initially, object x is moving in the positive x direction with a velocity of 4 meters per second. Object y, though, is moving in the negative direction because the velocity here is in the negative region of the velocity. Okay, it's beneath the t-axis. So this is -2, and then after the collide, they stick together and move off to the right at a rate of 1 meters per second. And it's moving right because this is a positive 1 meters per second. So because they move off together, it implies that they stick. Okay, because they sticked, this suggests that this is a perfectly inelastic collision. So therefore I'm going to go ahead with pick choice B. Right, momentum is conserved, So therefore, I have to go with A or B. Choice C or D saying momentum is not conserved, which is kind of whack. So A and B suggest momentum is conserved, which is a true statement. It comes down to whether KE is conserved or not. In this case, this is a perfectly inelastic collision because I know from the graph that they move off together, suggesting that it is. Therefore, KE is not conserved, so I'm going to go ahead and select this choice B. Alright, and last but not least, this one was a little wordy, so if you need to, pause, read it. But essentially here, it's saying that the distance of one grid in these choices represents a change in velocity of 1 meters per second. Okay, and it's saying which of the following diagram could represent the direction and relative magnitude of the velocity of the cart before the force is applied and after the force is applied. And it wants to select two answers. So essentially here you're given an impulse graph, you're given a force versus time graph. The one thing that you can extract is the area underneath the graph, which tells you impulse. So the mass here of the cart is 1 kilogram, and of course it experiences some sort of impulse, right? Which suggests that there's some sort of force acting on it. So how do I figure out which graphs or which answer choices match this graph? So the first thing you should do is recognize that impulse is the area underneath this F versus T graph. So to find the area of this triangle, you can do two right triangles and multiply by 2, or you can just do one rectangle. So watch my cursor. From 3 to 4 is 1. I'm going to go all the way up to the peak of this triangle here. That'd be 4. 1 times 4 is 4. Or you can do two right triangle, and you can do 1 times 4, which is 4, times a half, which is 2. But then you have to double it up. So 2 times 2 is 4. So it's entirely up to you how you want to find that particular shaded area. I would just do a rectangle. Oh, it's a 1 by 4 rectangle. Okay. All right. Therefore, you can also now break down impulse into mass times change in velocity. I'm doing this because essentially it's saying which diagram could represents the direction and relative magnitude of the velocity of the cart before and after. So there's some sort of change in velocity happening here because there's impulse happening. All right. So here the area is 4. Impulse is broken down into m times delta v. Well, I know mass is 1, so I'm just going to substitute that in. So delta v here would just be 4 meters per second. Right? Because to get delta v by itself, you would just divide both sides by 1 kilogram. So 4 divided by 1 is just 4. But you notice here, my delta v, v being velocity, has half a direction, so my change in velocity here is a positive quantity. Right? So which two choices here matches this statement? So I need to find a choice that tells me the change in velocity is equal to positive 4 meters per second. Well, I'm going to go ahead and pick the top left here, which is A and D, and I'll show you why I did that. Because, well, the first one I chose is this one, right? Because it says that each of these blocks is 1 meters per second. Well, mass is 1, so if you think about it, V here is 3 meters per second. Well, this one, okay, V here is negative 1. I don't know why I put kg there. Excuse me if I here, let me fix this real quick. This should just be, excuse me, meters per second. Sorry about that. And then, okay, as I was saying, if you think about it, this is 3 meters per second to the right. This is negative 1 meters per second. But delta V is VF minus VI. VF here is positive 3. The function itself is negative. I carry that over, but VI itself is negative 1. So it would be 3 minus negative 1. So minus and minus makes a positive. So it would be 3 plus 1, which is 4. And the change in velocity is 4, which matches what we need to get from this impulse graph. Okay, so that's why choice A is one of the choices. The other choice, I think it's easier to do, is choice D. Well, if you look at it, the velocity here is 5 blocks, which is 5 meters per second in the positive direction. And if you look at the initial here is a positive 1 because it's moving to the right. However, change in V, once again, is just VF minus VI. Here, VF is positive 5 minus VI is positive 1. 5 minus 1 is 4. So it matches what our change in velocity needs to be, which is a positive 4 meters per second. Okay, so those are my answer for this particular problem. All right, I hope that helps. Stay nerdy. Don't get trolled.